Hey guys, Mike here from Applied Engineering and Design, and we're going to go ahead and go through a tutorial on flip milling with RhinoCAM. Flip milling is basically where you need to mill on both sides of the part, whether you got to do work, engraving or anything, but either way you got to flip the part and do CNC machining on both sides. So what I did was I created this little part, kind of looks like a wheel here, with some inlay, some holes, and some more inlay and features on the bottom as well. So let's go ahead and get started here. What we're going to do is bring down our RhinoCAM and load it up here. And we're going to work mainly in this perspective view here. So first thing we want to do is make sure that our post-processor is set up and our machine is properly set up. Mine is still set to a 4th axis because I was doing some machine work programming on a 4th axis earlier. So what we're going to do here is first start off by selecting our stock. And we're going to go ahead and pretend that we're just using a standard vise that this is going to be held into. So we're going to go ahead and do copy model bounding box. And what we want to do here is give it a little extra on all sides, just because we want it to hold in place and kind of fall out after we flip it. So we'll let it go ahead and pick the 0 coordinate. But we're going to set our dimensions. We're going to add an inch on all sides. So we set this to 6, and we're going to add 6 here as well. And our height, since we want to make sure we do some facing operations, we're going to set this to 2 as well. So if I go ahead and hit OK, turn my stock back on, and you can see that it's significantly bigger than the part. But we can go ahead and fix that. Come back in here to stock. Copy model bounding box gets us back down to 4 there. And let's go ahead and just change this to 5, 5, and 2. And you can see that gives us a little bit smaller. That way we don't need as much big stock in the real world. You wouldn't waste that much stock for a part like this. So let's go ahead and align them. I'm going to go up here to align stock. And our Z alignment is going to be centered. And you can see this in here that we want it centered. That way our part is sitting right in the middle in our Z. And our XY is also going to be centered as well. So let's go ahead and hit OK. And you can see that looks pretty good with an even distribution around the outside as well as vertically. Next, we want to align our stock to our 0. And in my vise, typically I0 top left right up here. Obviously your hard jaw's on the back, and I always do that left corner there for whatever reason. So let's go ahead and set our world. We're going to do set to stock box. And what we're going to do now for our Z is we're going to go ahead and set lowest Z. That way I can go ahead in the machine, touch off on the bottom of the vise, add the value of the parallels to it, and when we flip it, we have the exact same Z as well. So I'm going to set this to lowest Z, and it's already set to northwest, which is correct. So we're going to hit OK. Moves everything kind of to where it needs to be. Cool. Hopefully you guys are following along. If you are struggling at all, go ahead and watch my intro video that we released before this. So first what we're going to do, I like to kind of keep things organized, so I'm going to go ahead and change the setup here to op1. I'll put dash top because that is going to be our top operation here. So first thing I want to do is I want to go ahead and face the block down all the way down to this circle here. And we're going to leave it a little strong because we want the part to drop out. So we're going to face only what we need. So let's go ahead and do 2 axis. And we're going to do facing. We're going to select our drive containment region. I'm going to pick this outer ring right here, that poly surface edge, and right click. For tool, let's go ahead and create a tool. We're going to do an end mill, and we're going to do this with let's do it with a 5/8 inch end mill. Set our diameter. And for all intensive purposes for right now, this doesn't matter, but we'll go ahead and put some information in here as well. And we'll leave it at tool number 1. We're going to work with aluminum right now, so I'm going to use my 3-flute end mills, turn my coolant on, jump over to feeds and speeds, load from file, change this to aluminum 6061, carbide end mill. Surface speed is usually pretty generous in the defaults, so I'm going to drop this down to 1200, and we're going to leave the feed per tooth 4 thousandths right now. Make sure we change our tool diameter and our flutes. We're going to go ahead and leave everything else the same. Save as new tool. Okay. Feeds and speeds, make sure everything looks good. Clearance plane looks good. All right, roughing. We're going to go ahead and leave tolerance and stock alone because we're just facing. Tool diameter, we're going to change this to 50%. Cut levels. Since this circle is at the bottom of where we want to be, we're going to change this to bottom. And because we have a 1/4 inch on top and on bottom, we're going to set our total cut depth to 1/4 inch here. And we're going to do a rough depth per cut of, let's do 75 thousandths so we can see this pretty well. Entry exit, we're going to do long path and nothing on the exit. Advanced cut, we're going to turn on our arc fitting with a 2 tolerance fitting and some smooth connectors. Let's hit generate. You can see it went in and it's going to face all this off in the middle here. As you can see, the entry right there is going to come down nicely into the part. So if we go ahead and simulate this, you can see what it'll look like. And there's not a whole lot to take off at each pass, so we can speed this up. And it's going to take it down exactly where we need it to go in about 5 steps. 4 steps, it looks like. So cool. All right, back at it here. I'm going to turn off the tool path for now so we can see a little better. The next thing we're going to do is let's go ahead and pocket out this inside here. Remove all the material from there. So we're going to do now 2-axis pocketing. Select. I'm going to click that, the inside surface edge there to give us that ring. And actually, we're going to do this a little different. Let's select the top one here, since we know we've already faced down to there. So right click, tool. I'm going to do it again with our 5/8 end mill. Oops, I jumped through and feeds and speeds. That's good. Clearance is good. Cut parameters. Now is where we want to get a little more tighter. We're not going to go ahead and do any finishing, so we're going to leave 0 stock. When I leave 0 stock, I want to make sure my tolerance is 1/1000th. And we're going to do 50% step over again. Our cut levels now. Cut levels is this line is at the top. So our depth control, I'm going to go ahead and select this, pick a point on the top circle, on the bottom circle, and gives us 3/4 of an inch depth, which is correct. And our ref depth per cut, we're going to do about, again, 75 thousandths per cut. Entry, this time we're going to helix in. Advanced cut, we're going to make sure we turn on our arc fitting and smooth cut connectors, and we don't need to worry about sorting for right now. So if we generate and take a look at the tool path, looks pretty good, except it's going to take that nub right off in the middle. What we did was we forgot to select that line in there as well. So let's go ahead and go back into here, and under drive region, I'm going to choose that line as well. See, now it only picked all of them. So let's remove all, select that, like that, and select that line. Okay, generate. Oh, still having a problem. And the reason is because they're on two different Z levels right here. So we have two options. We can come in and put a void there. But since we're using this top surface, probably the easiest way to do it is we're just going to do a quick dupe edge for duplicate edge. I'm going to select that edge, right click, and that gives me a curve for that edge. And what I'm going to do is drag it straight up to the same level as that top line. And let's go back in and remove all. And we're going to select both that edge and this curve, now that they're on the same plane, and generate. And now, perfect. Goes right around that area. So let's see what that looks like in the simulation. And that looks pretty good, other than it's not as close as we want it to be in the center there. And the reason being is that our step over tool size. So if we come back in, cut parameters, clean corners, generate, it should come in and do a clean corner operation on that as well. Let's go ahead and simulate through it. There we go. Got that nice small circle in the middle where we want it to. Cool. So that's looking pretty good. Now, next thing we're going to do is face down the pocketing for right there. And that'll be a quick operation to bring this down to that level. So 2-axis facing, select that operation. And actually what we can do, since we already have this circle here, is let's go ahead and choose that same edge we duplicated before. Tool is going to be the same, feeds and speeds are the same. Roughing now can stay at the looser tolerance with a little stock. Our cut levels are actually at the top, and our depth is going to be from this top surface here down to this surface right there. Gives us a 1/2 inch. And we're going to do this at 100th thou at a time. And now we can actually do our 2D entry and 2D exit. Same thing, turn on our arc fitting, smooth cut connectors, generate, take a look at the toolpath. Pretty much exactly what we need. Quick simulation. Oh, that's what we should need. Oh, it started at the top, so there we go. That one, this one, and here. Resimulate, takes it down. Turn off the toolpath. Starting to look pretty good right now. Cool. So now let's go ahead and drill those holes. Now let's check what size I made those holes. So we're going to go to Analyze Diameter. I already had that selected. Analyze Diameter. Put it on that. And those are 1/2 inch circles. So let's go to Holes. Drill. I'm going to select drill points or circles. And I've got curves and edges there, since the curves I used for doing the wire cut in Rhino, which are right on that edge. So we're going to go ahead and use the curves that are already there. total of 6 holes. Right click, tool. I'm going to use a drill this time, 1/2-inch drill. We have tool 2 since it's the second tool we're using. Feeds and speeds, if we load from file, again, lower this to about 1200. I'm going to lower this to about 2000 feet per tooth. And OK, save as new tool, OK. Feeds and speeds should auto load. Clearance, we've got clearance at the top. Cut parameters, our drill depth, because it's going to be from this hole down through. And so we don't actually need a whole lot of depth right here, as you can see. So we're actually only going to drill about a 1/2 inch like that. If we want, if we choose top and bottom, the hole actually is only 1/8 of an inch thick. So we could do that and then do add tooltip to drill depth, but just to be safe, we're going to go ahead. Why don't we drill 3/8 deep? Leave everything else the same. Sorting, we'll do minimum distance sort and hit generate. And if we take a look, it just goes right around in a circle. Let's see what that looks like. And obviously it's not drilling all the way through, but it puts nice holes. If we take a look now, that's pretty much everything we're going to do on this side. Now we could start the profile around the outside. And if we take a look at what our distance is of this outer piece from here to there, it's a 1-inch piece, which shouldn't be a problem for a larger end mill. But the issue is we don't have a ton of room. So think of your vise going to be at the top and at the bottom here. So what we're actually going to do is we'll probably end up doing it with a 1/2 inch end mill, which usually won't have enough length of cut. And if we want a real nice finish like that, why don't we start it and go down just a little bit as well. So if we go ahead and do 2-axis profiling, choose this outer edge tool. Let's go ahead and create a 1/2 inch end mill now. We're going to give ourselves a 1-inch flute length. Since we changed it here, you can watch what'll happen when I select OK. Load from file. Three flute, everything looks good. Hit OK. Now, if I do save as new tool with tool number 1 in here, it's going to pop up and say tool number is repeated. Do you want to use a non-repeated tool number? Well, yes, I do. We hit OK. It auto adjusts it to 3, and we're good to go. Select our 1/2 inch end mill. Check our feeds and speeds. Clearance plane looks good. All right, cut parameters. Now, right now I'm going to kind of do an easy part here. We're going to just do outside, inside for closed curves. Do outside because we know we want to cut around the outside. And our cut levels are, since this is 1 inch, going to be 1 inch down at this point. Why don't we go ahead and do, since there's a lip and there's some stuff in the way, we're going to only cut down about 1/2 inch. And we're going to go ahead and do 100th thou at a time. So 5 passes around. Our entry exit, I want to do it along the path, and I don't want any exit. Going to do arc fitting, 2000ths, and smooth cut connectors will not be affected here. So hit generate, and you can see it's just going to cut down just like that. And what we can do also is set, if we want, the entry and exit to apply at each cut level. And you can see that it'll come back up and down to smoothly go into it each time. So if we simulate that, let's see, it's actually awfully tight top and bottom. So we got two options. We can either make our stock bigger, or we'll just go to a smaller tool. So let's go ahead and do a smaller tool. I'm going to go in here, tool, edit tool. Let's go ahead and change this to a 3/8 end mill. We'll adjust our feeds and speeds. Okay. Say that it's two tool, and it tells us that we're editing existing tool. Hit OK. Choose our new tool. Make sure feet come into feeds and speeds. Hit load from tool so it loads the new feeds and speeds. Hit generate. Simulate again. There we go. Now there's plenty of meat at all four sides to hold it in place. Cool. So that whole side here is done now. We do have a hole in the middle. It's a through hole. We're going to go ahead and drill that from the other side. And you know what? We'll do it from this side. Why not? Go ahead, holes, drill, select circles. I'm going to select that one. Right click, tool. Let's check what size tool that is. We'll analyze diameter. Since it was already selected, it shows diameter of 1/4 inch. So we need another tool. Drill. 1/4 inch drill. Go ahead and just edit this one. Change our feeds and speeds. And for instance, my CNC machine tops out at 12,000. So we're going to go ahead and put 12,000 in there. Hit OK. Save as new tool. Same thing. Do we want to use a new tool number? Yes. Hit OK. Feeds and speeds, load from tool, clearance, cut parameters. Now we have a drill. So drills are typically longer. Let's figure out what our depth is going to be. It's going to go from there down to here. It gives us 3/4 inch, which is fine. So what we're going to do is let's drill a full inch. And we're going to peck drill it. So let's go to deep drill, full inch. We're going to do it in like 1/4 inch drill bit so we can do 2 pecks. Generate. Simulate it. Good to go. Cool. All right, let's flip it. So next, we know that we zeroed off this upper left corner. So to make sure that when we flip this block to the other side, that we are touching off the exact same surfaces, that's important. So let's go ahead and we're going to collapse op 1. And I'm going to go ahead and create a new setup. So new CSYS setup. And what we're going to do is I'm going to hit select surface, and this will allow me what surface I want to look at. So I'm going to rotate it all the way around. I'm going to select that surface. So now if we take a look at our coordinate system right here, it's at that exact same corner now for where we flipped it, which is good because we are going to touch off that corner again. However, the way it's showing, and it gets a little hairy with doing this, is technically with our Z going this way, our X and our Y is the same, but our X is flipped. So let's go ahead and hit OK. That's one thing I wish it would only show one at a time here. So we're going to do op2 and do bottom. And what's important here, like I said, is to make sure we're touching off this exact same corner. Now, this is at the top of it. So technically, we want it to be at the bottom because we're touched off and are zeroed out at the parallels. So we're gonna come in and set work 0. We're gonna set the stock box, and it's gonna be lowest Z. And because we want to be at that corner again, is now we're gonna be, northeast. That will technically be that same corner that it was up here. And you can see that now it's correct. So, and for instance, for here, let's say this is going to be G55, so we can have it both touched off right in the beginning. Generate. Cool, and that's it. So now we know we're going to be touched off at that exact same point. Let's start adding some machining features. So what we're going to do now is same thing we did before. We're going to face it down to that surface. So 2-axis facing, select region, select this here. We have a curve here, probably the curve I used to create it. I'm going to right click, tool. We're going to use that 5/8 end mill again. Feeds and speed should load automatically. Clearance plane is now on the correct surface side for where we are. And the roughing can stay the same. The tool diameter, we're going to do 50%. Cut levels, we're at the bottom. And it looks like, why don't we go ahead and we're going to pick the smaller one first. I'll give you an idea of that because that's going to pose. We're going to have to do this down in steps, which isn't a big deal at all. So, first thing we want to do is face it. Actually, we'll just use this one here. So let's face this. Our cut depth is going to be, think with me here. We're going to be here and it's going to be above there. So we're going to go ahead and do total cut depth of 1/2 inch. And we're going to do 100 thou entry exit. It's going to be a long path. Advanced cut parameters, perform arc fitting 002, and smooth cut connectors will be on. Generate. Now, if you take a look, it's basically going to clean everything out, including what we don't want. So how do we fix that? We're going to go ahead and take this curve that we used, and we're going to drag it up to that surface. And if we regenerate, puts it all above it. So let's do a quick simulation. And you can see we did a little too much here. So we did 2 passes without it even touching. Cool. So let's go ahead and jump back in here and alter that real quick. Cut levels. Let's just do generate. Simulate quick again. Yep, we're good to go. Should do it in 3 passes. Cool. All right, so next we're going to go ahead and face the same stuff down. Now we're going to face down to this next surface level here. So we're going to duplicate this ring, and I'm going to do a little shortcut here by just holding Alt and grabbing the gumball, releasing it so that I can lock it to there. And now it went down a little low. We actually want it locked into this surface right here. We're okay, which is actually that next surface. So now what we need is we need this center ring here. which in order to get that, we're going to do a dupe edge. We're going to duplicate this edge right there, right click. Now we got the two edges we need to work with. So we're going to do the same thing. I'm going to go ahead and grab 2.5 axis facing. I'm going to Control C, Control V, go in, clear these, select my points or my curves. We're going to do this outer curve here, this inner curve there, right click, generate. Take a look at the toolpath. Looking pretty good. Let's take a look at it. Not bad at all, and you can actually, it even simulates and shows the holes that come through there. Very cool. I'll make sure we have corner cleanup on there in case it wasn't getting too close. It looked okay to me. Actually, that's why I picked the wrong curve here. So let's do a dupe edge. We actually wanted that one. I think there is a curve there. Yep. Okay, cool. So go back in here. Let's remove them. I'm going to select that one and this inner one. Right click, generate. See how it moved it in nicely. Cool. So without simulation, let's move on to the next one. The next thing we're going to do is now we're going to do a dupe edge on the inner one and create this pocket. Now we have a line there. We've already got a curve right here. They're at the same plane. Great. Let's do 2.5 axis pocketing. Select our regions for containment. Is going to be that curve and this curve. Right click, tool. We're going to do it with our trusty 5/8. Cut parameters now. Our tolerance is going to be 1,000, 0 stock. Turn on clean corners, 50% tool diameter. Cut levels, we'll go ahead and choose the 2 points that I know we want. Gives us an 1/8 inch down, which is correct. Going to helix in. Going to turn on our arc fitting and smooth cut connectors. And for cut levels, we're going to do the whole, we'll do it in, just to be safe, we'll do it in two passes of 1/16 inch apiece. Generate. You can see the toolpath right there. Let's go ahead and simulate. We need to watch this one, which is what we had just done. And we'll simulate this one as well. Not bad. And that gives us our little step right there. Now, that pretty much completes this other side here. We have a little bit of pocketing we want to do on the inside here. So let's go ahead and do that. I'm going to dupe edge. Grab this edge here, which actually we don't need to. We can go ahead and do 2-axis pocketing, select the region. RhinoCAM is nice and lets you select right on the surface edge. Tool, we can do this with our 3/8. Feeds and speed should be loaded automatically. Tolerance of 1,000, stock of 0, step over of 50%. Our cut levels, I'm going to go ahead and pick them. They're down to there. It's 1/4 inch. 75 thou per pass. Helix in. Arc fitting on. Smooth cut connectors on. Generate. We can see it's just going to pocket that right out. Simulate. Cool. So this is looking pretty good now. Looks very much like the part, and we're pretty much ready to cut it out. Now, I can see one issue right now. We're going to need a pretty long tool to do that. So we have two options. We can create another operation where we flip it back over and it cuts it out from the other side, which is the more you move the part, the more chances of error you have. But in this case, we actually need a fairly long tool to cut this last part out. If we measure sort of where it is, that's pretty far down. Since our part is, if I measure from there to there, our part is 1 inch from here. And about a ½ inch more. So about 1.5 inches down. It's only a 1 inch, a ½ inch cut we need to make, but there's a lot of material right here. We actually need a pretty long tool. So let's say we were going to get a tool just to do it this way, so we don't have to flip it again, and that's going to make it a little easier for this tutorial also. So we'll treat it like we have a completely different tool to use. 2-axis profiling. And our region is going to be this outer region right here. Right click. Tool. All right, we're going to use the 3/8 end mill, but let's pretend this is a completely different tool that we're going to use to cut this out. So we're going to come in here and call this 3/8 long end mill. And just for accuracy, we're going to say it's a 4-inch tool, and we've got 2 inches length of cut. We're going to save it as everything else can be the same. Save as new tool. Tool number repeated. We want a new tool number. Hit OK. Select our long end mill. Our cut levels, it is at the top. And our cut depth is going to be, we want to make sure a part falls out. So we're going to do just over. We're going to do 0.55. And because we want that last piece to sort of come out nicely here, we're going to maybe use bridges here, which would probably work out pretty well. So, but let's say we're not going to use bridges. Let's do a finished depth of 10 thou, which is going to leave 10 thousandths thickness, and do that in a last pass. So our rough depth per cut, I'm going to make sure we're only doing about, since it's a real long tool, 50 thousandths roughly per cut. Our entry per exit is going to be a long path. No exit. We want to make sure we do it at each one. Advanced cut parameters. We are going to do arc fitting. We don't need to do smooth cut connectors. And here's the bridges and tabs I was telling you about, or I just mentioned. Creating bridges would actually create little sections where it would jump up and jump down and leave it connected. In this part, it's probably not worth doing, but if we were doing like a flat part, something that was out of flat stock, it would be nice to have the tabs you break off later if you didn't want it to fly out and break your tool or something like that. I've actually had that happen on some parts. So we're going to go ahead and hit generate. And I made a mistake. Didn't choose inside or outside, so let's go back in. Cut parameters, use outside, inside. We want outside, generate. There we go. There's our path. So now if we simulate, it's going to go ahead and clean the rest of that out. There you go. Part at this point would have fallen out. Completely done. And that is quote-unquote flip milling. Basically, a lot of shops will use this. I use it a lot for working on two sides of a part. It's nice to have this square block to sort of zero off of and hold it in place for each time. So there you go. Pretty short, easy way to do it. Not too long. Shouldn't take you long to do stuff like that and set it up. But if you set it up correctly like this, you can make sure you have accurate parts. And you would set this up once and then go run production if you had to make a bunch of these parts. So if you have any questions, feel free to leave a comment or contact me at info at appliedengdesign.com. Make sure you subscribe and like the videos and everything. And if you guys have any suggestions for more videos, send me an email as well. And hopefully get you guys some more information soon. Thanks.